Alright, here is a typical exam question. We're going to try and solve this by hand so we don't spend too much time typing it out. Show that the integral of 1 over the root of x squared plus a squared is equal to ln of x plus the root of the same plus c. Alright, if you've been following, then you know we need to use a substitution here, and we're going to make use of a trigonometric substitution. Because I see x plus a constant here, my mind takes me to trigonometric identities, in particular the tangent identity. The tan identity says that 1 plus tan squared of x is in fact sec squared of x. So because of this plus and 1, which is or a constant, and tan squared, I'm going to use that substitution here. So what do I do? So I will say let x there be represented by a tan of a new variable that's going to be theta. So we'll use theta for our new variable. If I differentiate this, I get dx equals a sec squared of theta d theta. All right, now I have my x and I have my dx. I'm going to substitute those into my original expression or integral. So dx, where there is dx, I'll replace with this. So that is a sec squared of theta d theta. And where there is x there, I'm going to put a tan theta. So clearly that becomes root of a squared tan squared of theta plus a squared. And now you can see why I chose to use the substitution of a tan theta, because I end up with a squared here, which I can factorize with the original a squared that was there. So this becomes what? If I take this a out, I end up with a divided by a integral of sec squared theta d theta over root of tan squared theta plus 1. Now, tan squared theta plus 1 is this, the whole reason why I used this substitution. And so I can remove this here and put sec squared of theta, but then there is a root there, square root of sec squared of x, or squared of theta in this case, is just going to be sec theta. So a and a have cancelled, and I can now write my integral as sec squared of theta divided by sec theta d theta. So in fact this is sec theta d theta. And if you look at a previous video, the immediate previous video, we've just shown that the integral of sec theta d theta is in fact ln of sec of theta plus tan of theta plus c. And so that is the integral. But we are not done, because our result has to be in terms of x. Now, if you look up, we can see that here we had agreed that we use the substitution tan of theta was x over a. All right, so I know that for tan theta, I'm going to put x over a. However, what about sec? To find out the expression we put for x for sec of theta in terms of x, we draw a right angle triangle and think about the basic trig identity. If this angle here is theta, then tan of theta is opposite over adjacent. So x over a would suggest that x is my opposite and a is my adjacent. And if I have these two, then I can also find the hypotenuse. The hypotenuse becomes the square root of a squared plus x squared. So I can write this, the hypotenuse there is going to be x squared plus a squared. That's supposed to be a squared. I hope you can see it clearly. And because of that, sec is the reciprocal of cosine. So cosine is adjacent over hypotenuse, and therefore sec must be hypotenuse over adjacent, the reciprocal of cos. And so this can now be expressed. So we are saying that sec of theta can be expressed as the square root of x squared plus a squared, everything divided by a. And now I can write this as ln of root. So for sec, I'll put this x squared plus a squared, everything over a, plus for tangent, this is not there, c is out. So for tangent, I can put x over a like that. And I have my plus c. If I combine these together, I'm going to draw a line here. If I combine this together, it's just a fraction. The integral is ln. A is in the denominator, the square root of x squared plus a squared, right, plus x. And everything there plus c. I can write this simply as ln of, this is, because this is log, I can subtract. So I can write this as x squared plus a squared, everything plus x. And I can say minus ln of a, and I can say plus c. And then these two, this is a is a constant, so ln a is a constant. If I combine that constant and this one, I just get another constant. And so I can write this as ln of the root of x squared plus a squared plus x outside. And then I can just say plus some constant c, some new constant c. I could use a or whatever it is. And we have shown that the integral of that expression result into this. All right, thank you. I hope this made sense. You realize that in order to cut it short, we needed to remember this integral. So please remember the integral of sec theta is given by this. All right. Thank you. I'll see you in the next video.